I'm your host, Kyrie Douglas, and welcome to Catalyzing Computing, the official podcast of the Computing Community Consortium. The Computing Community Consortium, or CCC for short, is a programmatic committee of the Computing Research Association. The mission of the CCC is to catalyze the computing research community and enable the pursuit of innovative, high-impact research. We are joined today by CCC Council member Suresh Venkatasubramanian. Suresh is a professor at the University of Utah. His background is in algorithms and computational geometry, as well as data mining and machine learning. His current research interests lie in algorithmic fairness and, more generally, the problem of understanding and explaining the results of black box decision procedures. Suresh received a career award from the NSF for his work in the geometry of probability, as well as a Test of Time award at ICDE 2017 for his work in privacy. He joined the CCC Council this year. All right, so I guess we'll kind of get into some questions now. So your background is in geometry, right?
Yep.
Initially, how did you decide to study computer science?
The earliest memory I have of being interested in this was basically reading a book about the Turing test. I grew up in Delhi, and there's this British Council library, which is a nice library we used to go to. And there was a book there on the Turing test. And so I read the book. I think I read Gödel, Escher, and Bach around the same time, maybe a little bit later. That's when I first started getting intrigued by this idea.
Okay.
And, computers, they weren't really, this was the early 80s, so computers weren't quite a household name yet. But there was this idea was out there. And my father had actually done some punch card stuff at the time.
Really?
And so one thing led to another. I got a computer, the first one, and started fooling around. And I think things went on from there. It wasn't clear that I would be doing computer science. I didn't know what computer science was at the time. But it was definitely something I was very interested in.
Do you know what the book was that inspired?
No, I don't. It's tragic. It wasn't even a particularly famous book or anything. It was just a book that happened to talk about Alan Turing and the Turing test. Not even Turing machines, the Turing test. I'm now realizing the strand in my thinking. Right, it was a philosophical thing. Right, so how do you think about what it means to have a mind and to have intelligence? And so that the Turing test was framed in that context. And I feel like philosophy has been haunting me ever since then. I do a lot more work talking to philosophers now, but I feel like it's been there in my background ever since then.
Really?
That those are the kinds of questions that appeal to me.
So how did you end up in the United States from India?
So at the time, and this is not so true now, but it was very true then, when you were a student in school in India, right, you had to essentially decide, or at least make some kind of decision about what you wanted to do with your life when you were in basically 10th grade or 11th grade. And the reason is because there were these streams, right? Either engineering stream or a medicine stream. And those are the only real streams that led to sort of profitable paying professions. Everything else, then your parents would get worried about what you're going to do with your life, and it would be very full of tension and all kinds of other things. And I know because my sister went through that. So you had to kind of say, okay, am I an engineering person or a medicine person? And it boiled down to, do I like math or not?
Okay.
If I like math, I'm an engineering person. If I don't like math, I'm a medicine person. So I like math, so I became an engineering person. By then, I was very much interested in computer science. So once you do that, then if you're going to do engineering, what are you going to do? You're going to apply to the IITs, which are the biggest, most famous, or the Indian MIT, if you wish, the place to go, right?
Okay.
So
how big of a school is that?
It's multiple institutions, right? So now there are 14 of them. At the time I applied, there were 5.
Oh, wow.
And there was a common national entrance exam. And so it was like 2 years of coaching to sort of get ready for the entrance exam. And then you took the exam, and then you get a rank, right, out of 1 out of 100,000 or whatever. And then based on that rank, you would get a chance to bid for a institution and a discipline. So it's kind of weird, right? Basically, if you did well, you got to choose the popular disciplines. And if you didn't do too well, you got to choose the less popular ones, which had very little to do with what your actual interests were. I mean, if your interests were in something unpopular, that was fine. But if you didn't do well in the exam and you wanted something popular, then you'd have trouble.
Right.
And so computer science was a popular discipline. And luckily enough, I got a rank high enough that I could bid for computer science. And so then I started doing computer science. And then once you do that, once you're in college, again, your options were pretty much circumscribed. At least in the IIT that I was, you had 3 choices. You either go to grad school, you go to an MBA, or you go into the Indian Civil Service. These are all sort of solid career tracks. Coming from an IIT, you get the stamp of approval that makes you sort of highly qualified for any of these things.
Right. And so grad school always seemed like it was the next logical move, or?
I always, thought that would be the next step. I didn't think about, I want to do a PhD, but it seemed like the obvious next thing to do.
Really?
Yeah.
So you always thought about going to grad school, and then you already had family in America.
Yep. I was born in England, and I grew up when I was very young in England and America. So even when I was in India, there was always this sort of connection, right? And I had uncles who were in the U.S. My sister came to the U.S. to do her grad school in English, actually.
Oh, really?
And so there were people here already, so it wasn't unfamiliar for me.
Okay.
Yeah.
So then you went to Stanford.
Yeah. So the funny thing was, I think I came to Stanford thinking I would do AI. And then I went and talked to a professor, and they gave me a proceedings of a conference to read. And I read those papers like, this is not what I wanted to do. so I went, hunting around, and my other interest was algorithms. And so I went and talked to Rajiv Motwani, who was there at the time, and one thing led to another, and I started working in algorithms. So this is again a thing for incoming grad students. It's okay to not always know what you want to do. It happens. It happened to me. Yeah.
So how did you get into geometry?
So geometry, for people who don't know, right? This is not the stuff you learn in high school with Euclid. I mean, it is, but it isn't. Also, it's computational geometry, which basically means if you're doing algorithm design, but your objects of study are not, numbers or graphs, but there's, let's say, points and lines and planes. The study of designing algorithms for those objects is called computational geometry. So at some level, computational geometry is a fundamental tool that shows up in graphics. It shows up in sort of any kind of modeling. It shows up in machine learning. It's a very fundamental sort of operator or set of tools you need to understand the world around you. Because anything with geometry has shape. Anything with shape, we try to ascribe meaning to. And when we do that, we do this with machine learning all the time now, and you don't realize that underlying all of it is some kind of geometry of the space that we're working with. So it's a very fundamental sort of set of questions. As you can see, I still love it. So.
Yeah, that makes sense. So your dissertation at Stanford was on like pharmaceuticals, making drugs?
Yeah, making drugs. Sounds very cool.
So what kind of drugs did you make?
I didn't make any drugs, sadly, but it was fun.
Okay, so you weren't making drugs, but what did you work on?
Pfizer had come to my advisors at the time, Jean-Claude Latome and Rajiv Motwani. Interestingly enough, this is still a question, right? You want to design a drug. Okay. The way people think about drugs is that they operate on some kind of lock and key mechanism, where the lock is a protein, a drug is a key, and with the right key in the right lock, you can unlock an effect you want in the protein. And that's how the drug takes effect. Okay, great. But a drug is a complicated sort of floppy thing. Proteins are fairly rigid. They have a shape like a lock. But think of a drug like a key made out of rubber. It sort of changes its shape quite a bit. So figuring out what part of the drug molecule actually is having the effect. It's like saying, well, is it the pointy part of the key or the round part of the key? Which is the part? We don't really know which part is having the effect. So all you can do is you get a whole bunch of drugs, and they all seem to have the desired effect, but you don't know why, and they all have side effects. Can you figure out what's common between them? Right? The common key part of all of them that's actually having an effect. Because if you did that, you could then design a drug that only had that bit and nothing else.
Right. So that's where the computational geometry comes into play.
Can you think of this from a shape? So people had been doing this already, but they were thinking of this by looking at the chemical formula, looking at commonalities in the formula. And then people said, well, it's when you actually put the drug into someone's body, it has a shape, and that shape matters. We need to understand the shape and not just the letters in the formula. And so that's where, people like me come in.
Okay. So after Stanford, you ended up at AT&T Labs.
Yep.
Right? How did that transition happen?
Well, you do your PhD, you apply for jobs, you get offers, and you decide. I had an academic offer, I had an industrial lab offer, and I talked to a bunch of people, and they gave me all kinds of advice, none of which made any sense. So I spent 3 months agonizing over this, and my girlfriend at the time, now my wife, she got sick of me and said she doesn't want to talk to me about this again. And finally, I decided to go to AT&T. For me at the time, it was a tough choice. I think, like most choices in retrospect, it makes sense, or it makes sense in the sense that you rationalize it, so it makes sense.
Right.
But at the time, it was difficult. But I'm glad I did it.
Yeah. What kind of advice for people that might be listening and they're also struggling with academia or industry or two different job offers? What kind of advice did you get? Why was it not helpful? Or
so first of all, I think the conditions right now are so different the way it was then, right? So I don't know if anything I relay now would be useful. But the advice on the side of going to industry, if you want to end up in academia, right, then one way to think about industrial job is to treat it like an extended postdoc. You do a lot of work, you have very few responsibilities, you can do all kinds of research, set up a direction, and then you can get to academia. And this is good because now you have a nice research track going. So once you get to academia and you're slammed by the 1,000 things you have to do as a professor, at least your research is chugging along.
Right.
That advice, I think, is correct even today, and you see people doing this a lot. Like people will get faculty jobs, but they'll still take a 1 year or 2 year postdoc to do something else. And I think it helps them because you get that level of maturity and you get that level of seasoning of how to think about your own questions. So I think that's solid advice. I don't know if the companies are very happy about me saying this, but again, this is conditioned on if you want to go to academia eventually. If you're still dithering about whether to go to academia, then I think it's a different set of questions, right? Then so maybe go to industry, try it out for a bit, see what it's like. You know what the academic life is like. Go see what the industrial life is like, and then see what happens. I think my worry was, you go into industry, you get sort of stuck in a particular position for a while. It's hard to maintain your research viability, and you have to be careful about that.
Really?
And I think it's very easy to get sucked into whatever projects you're working on in a company, and then forget about the fact that you got to maintain external viability if you want to go back to academics.
So what's different about the research you're doing at industry that would limit your transition to academia?
Big companies, small companies, startups, they're all very different, right? So let's say if you're working at a big company like Google, it's possible you can spend a lot of time just working on sort of standard academic type research where you write papers. But of course, first of all, you may be working on very cool stuff that you can't write about, you can't talk about. You might be working on very fundamentally important things, but that they don't involve the certain kinds of novelty that are prized by the academic environment. And sometimes the right thing to do is not the novel thing to do. The right thing to do is just take something someone did 10 years ago, but just engineer the heck out of it and make it work. That's very valuable. But it's not, I want to be careful here, it's not always viewed as academically valuable in the same way. And it really depends on the perspective. The default mode is that novelty is what's prized.
Okay.
But there are a lot of caveats here. I don't want people yelling at me.
Right.
But I think that's often a challenge. I think the reason why people often go to industry from academia is that they want to have that experience of really deploying, engineering, building something concrete, and get the value for doing it, which you may not get value for or be able to do in academia.
Okay. That makes a lot of sense.
Yeah. So the advice I usually give students now is, think about what is it that excites you, right? If building things excites you, working with a team, then, maybe some kind of industrial environment is good for you. If sort of, thinking about long-range problems, right? Thinking about hard questions that there's no easy solution, thinking that time frame is important to you, then maybe academia is the right place for you. But these are all maybes. It's a very personal decision, I think.
Right.
And that's why it's hard to give advice.
So what kind of things did you work on while you were at AT&T?
Just a whole bunch of things, right? So, I mean, one thing at a company like AT&T at the time, in the research lab, one of our jobs was to, among other things, one of our jobs was to be kind of the consultants for the internal business groups, right? So they wouldn't come to me directly, but they might come to my boss or my boss's boss, and then that would eventually route through to me, right? Saying, okay, there's this question, maybe you can help. There was one particular project that lasted a couple of years where, they came and talked to us about something, and then we had some algorithmic solutions, and that led to a lot of engineering work, and that was quite helpful for a long time. I mean, I'm not sure I can say much more than that, but it was definitely a fruitful collaboration. And there were a lot of sort of smaller scale collaborations along those lines.
What was the time frame that you were doing all of this? When did you go to grad school, and then when did you go to AT&T?
Oh, now you're going to ask me awkward questions. Okay, so so I graduated in 1999, so almost 20 years ago. This is my 3-year plan that became a 7-year plan, basically. I had a 3-year plan to go to AT&T and go to academics, and that became a 7-year plan because I was lazy. And I was having fun. Then that's when I moved to Utah, and then I've been there since.
What inspired you to move to Utah? Just you got a job there, or had you always liked the West? And
I didn't know anything about Utah, but I was looking for academic jobs. And so I'd done my interviews, and, I liked the place. I came here, and it was nice.
You live in Utah, in Salt Lake City?
Salt Lake City.
How's that?
It's great.
Yeah.
It's in the mountains. People don't realize how, people talk about Denver, right? But Salt Lake is basically the same height. So you're 5,000 feet above the ground. So, and the mountains are right there. So I'm 20 minutes from the slopes.
That's nice. So do you ski?
Yeah.
Okay.
So I'm literally 22 minutes from the best skiing in the country. So
that's great.
So it's a good place to be. And that's why we're all waiting right now. Some resorts have already opened up.
Really?
A couple of places, yeah. And so usually after Thanksgiving, they all open. So
do you ski and snowboard?
No, I don't go to snowboard myself, but I could. I mean, there are basically 4 right next to my house, and I go to another one, which the locals know, but the tourists don't.
Oh, really?
So
can you say it?
So I'm not going to tell you what it is. Well, actually, it's called Solitude, appropriately enough. But I have been to snowboard a couple of times. Yeah, it's just a question of access and
right.
So snowboard and its partner are in a canyon that tends to get more snowed in. It's more narrow, so sometimes it'll just be closed up, whereas the other one is a bit more open up.
All right, well, that's nice. Of the classes that you teach now, what has been the most interesting?
So I taught a bunch of stuff, right? I taught a lot of these sort of standard theory classes, like graduate algorithms, geometry, randomization. I taught a seminar one summer on sort of different failed approaches to proving P versus NP, which was fun and just for me to learn. Sadly, the most fun class would be the one where I didn't know anything about the topic and tried to learn it. So it was great for me, but not so much for the students. But I think all these classes were challenging initially because I didn't want to I couldn't bring myself to just taking a standard course and copying it. I had to be annoying and do my own thing, trying to articulate my own vision for what I wanted out of a class like algorithms. How do you come up with a brand new interpretation of a Beethoven sonata, right? I mean, it's people have played it 100,000 times. The same thing, if you're going to teach an algorithms class, that's basically, the standard way to do it. How do you bring your own interpretation to this? So that's something I struggled with for a bit, trying to figure out what is it that I wanted to say when I taught algorithms to students. So I had to come up with that form. That took a couple of years to come up with a formalism for that. Same thing with geometry. I have a way of teaching it that I think is not standard, and articulating that clearly in class was also a bit of a struggle. Probably the hardest class I taught, though, was this recent one on the ethics of data science, which is something I was very ill-equipped to do, but I did anyway. Mainly because I'm not a philosopher, I'm not an ethicist, I'm not trained to talk about it. And the way to teach those classes is very different to the way you teach an engineering class. Engineering class is like, okay, here's the problem, here's the answer, here's the problem, here's the answer. In ethics, the solution is to discuss and look at the perspectives, the multiple perspectives. And you're not coming up with an answer, but you're learning how to apply these perspectives. And students find that very difficult. I found that very difficult. It was but it was fun. It was very illuminating for me also.
I guess ethics is really about the framework, the process that you arrive at the answer, not so much the answer itself.
Well, I think answer is very important. I think, and to be honest, I think, this will get me in trouble again, but I think it would be nice if the social sciences, spend more time thinking about the answers as opposed to the perspective. I think one of the fundamental conflicts between computer science and social sciences is that we are always looking for answers. And I think in many of the social sciences are looking for perspectives. You need perspectives, otherwise you come up with the wrong answer. But you need an answer, otherwise you don't know where you're going. So I would say that yes, ethics is really is a lot of it is about process and perspective. But you also want to get somewhere, especially when we're having these hard questions about the way we see algorithms deploying in the real world. It's important to recognize the problem. And I think that's what computer scientists are not always very good at. Having multiple perspectives, ethical frameworks allows us to recognize what the problem is. And articulating clearly is important. But then you need to know what to do. So I think this constant tension is there between, recognition and solution.
It's definitely true. I mean, as someone with sort of a social science background.
Oh, you do? I hope I didn't offend you.
No. Well, I studied international
Or if I did, I
studies
hope you'll forgive me.
and economics. It's just the challenge is always if two people are in conflict, resolving that conflict involves someone losing. So
you must be an economist.
Yeah.
But things are not always a zero-sum game, right?
They're not always zero-sum, but they're frequently perceived that way by the people, which is what matters.
Right. And I think getting beyond this, I think that's the thing. If you only have one perspective, then everything's a zero-sum game. I mean, they tell us this in negotiations, right? In academic negotiations. If everything's about your salary, then there's really nothing you can do. You'll ask for something, they'll give you something, and you'll either decide you get it or not, right? But if you make your space of negotiating more multidimensional, you have different perspectives, then you can give somewhere and get somewhere else. And I think understanding that in the context of algorithms is also helpful, right? It's not just about the accuracy. It's not just about the bias. It's about a bunch of different factors that you have to understand. And that's where, some actual real, I wouldn't say compromise, but real agreement can come from.
Are there any examples of algorithms that you can mention that resolve sort of things in multiple dimensions? Because I think a lot when you hear about algorithmic bias, you hear about say sentencing in the criminal justice system,
right? Which obviously
seems pretty zero-sum, but maybe it's not, or maybe there are other examples.
But it's not, and so even there it's not. So I mean, okay, the most obvious example I think, which I've given, is cake cutting, right? So this classic old 3,000-year-old problem of how to cut a cake. This whole I cut, you choose thing, right? So the idea is you have a cake and it has, a whole bunch of stuff in it and two people want it. And how do you decide to apportion it fairly among the two people? So the goal is not to divide it up equally because maybe one person loves icing, other person hates the icing. The goal is to divide it so everyone feels that they've got what they wanted.
Right.
And so the whole fair division problem is how do you do that? And the I cut, you choose idea basically says, look, if I cut it and you choose, then if I cut it badly, it's my fault. And if I cut it according to what I want, you take what you want, we're both happy. And so, I mean, that's a very simple example of how, in fact, the more people disagree on what they like, the easier it is to solve this problem. So it's a weird paradoxical thing where, if you hate cake and love icing, and I hate icing and love cake, this is a very easy problem to solve.
Yeah, you just give me all of the icing, you eat all the cake.
But if we both all love cake and hate icing, then we have a problem. So when we agree on the value, it's harder to divide than when we disagree. So this is one of those things where disagreement is a good thing. But you just have to identify the multiple dimensions along which you might agree or disagree.
Okay.
Now, in the case of the sentencing system, right? I mean, so first of all, I'm not saying that this is an easy problem. It's a very, very complex problem, and I don't think algorithms are the solution, but they're part of a larger solution. But even there, you have to be more careful about saying, what are your goals here, right? If you're trying to say, do a pre-trial risk assessment, right? Do you release people pre-bail? It's a big topic right now in the world. Then there are multiple things you could say. Okay, you're worried about people not showing up in court. You're worried about people someone committing a crime while they're out before trial. You are, you have different ways to keep track of whether people can show up in court or not. People might not be able to show up in court because they have a job and they can't afford to leave their job. And so there's all these factors. If you start considering, the problem becomes more nuanced and more complex, but also the solutions start appearing. Mm-hmm. And I think, avoiding sort of a single binary release or not and allowing yourself an option space that's broader means that you actually can find a way to get somewhere that keeps all the stakeholders a little bit more satisfied than they would have been.
So that involves, say, like probationary periods of various kinds? Or
a supervised release and monitoring systems, all kinds of things. I'm not endorsing any of these, but I'm saying that with the more options you have on the table, the more wiggle room you have to play with possible solutions that can satisfy different stakeholders. And that's something that is hard to do in algorithms sometimes.
That's definitely good food for thought. You're also involved with the ACLU. Can you talk a little bit about those projects?
So I think sort of spiritually, I've been a member for the ACLU all my life, in the sense that, ever since I came to this country, I kind of felt the way things are going on that being an immigrant, being, a brown-skinned immigrant, that the ACLU is the only entity that is going to have my back no matter what.
Right.
Right. Political waves come and go. An organization like that sort of built on principles is always going to support or going to help. And I've seen this happen time and again. So I recently, 2017, I got on the board of the ACLU in Utah. So I was invited to be on the board, and I'm very grateful for that chance to be there. The ACLU in Utah does amazing stuff. And I think what people don't often realize, because they only see the court cases, is that the ACLU is not just about court cases. It's only one of the many things they do. Oftentimes, and we see this in Utah, right, that the ACLU will work with the politicians. They'll work with the legislators to sort of make sure a bill looks better or make sure a bad bill doesn't get through. And you won't hear anything about this. It'll all be just under the cover. But it's a large portion of what they do. Okay. And sort of lawsuits are kind of a last resort when other things fail.
Right.
So I think this idea of, you work with the government agencies and other groups to make something happen. You find points of agreement, you find points of compromise, and make something work, as opposed to just sort of flame throwing. That's something that I didn't know about the ACLU, and I'm very impressed by. So I'm really glad that I'm kind of part of that group and what they're doing there.
You're also on the Research Advisory Council for New York City's effort to build a failure to appear risk assessment tool. How does that work?
Basically, they're building a new tool to do risk assessments, and they've brought in a bunch of people who have expertise in different aspects of this problem, right? So not just computer scientists, statisticians, criminologists, lawyers, public defenders, people like that, and sort of to see how they're building the tool and get our opinion and have us weigh in on some of the things they're doing. So that's been a very interesting experience to see how things get built from the inside. Very cool.
Has getting more involved in how the political sausage get made you want to run for office or ever considered anything like that?
No. Have I said no enough times?
Not even city council or...
I don't think I have the skills.
Yeah.
I mean, I can see how it gets done, but it's not that, I don't want to because it's distasteful. I think it's very hard work, and the people who do it, kudos to them for doing it. I don't think I can. I don't think I have the kind of personality that goes along with actually being in politics.
Really?
You have to like people at some point. You have to be able to interact with people. And I'm much more comfortable in in the research world, thinking about these questions. And one never says never with these things, but I think my skills are best where they are, just being a researcher who thinks about these questions.
Could you maybe pitch people on getting more involved? People are listening to this that have thought about getting involved in their community, local government, using science to material effect and improve people's lives.
Yeah, definitely. I mean, so there's no question that we are heading into a world of data science and algorithmic thinking. We're already there in many ways. And people like me, people who are trained in computer science, right, have skills we don't realize we have to model, to compute, and to understand how the raw tools of machine learning and algorithms work in ways that others just do not have. And so just like, many years ago, lawyers decided that being poor was not an excuse to not be able to have good representation in court. And they built a whole pro bono system around defending people who could not defend themselves, the whole public defender system. I think we need data scientists to do pro bono work. Especially in local governments. So you see a lot of problems with local governments where they would like to do something useful the data have. They just don't know how to do it. They don't have the technical know-how or the resources to do it. Especially if you work in data science, you can make a good living working at your job. But you have skills that can help really make things better in a careful, nuanced way. And I'm not saying, wield the algorithmic hammer and sort of claim you use technology to solve everyone's problems. I don't think that's true. But I think you can work with the local governments. You can work with local authorities to understand their questions, come to them on their terms, and be useful in ways in which, in places where they may not have thought about or may not be able to articulate the ways in which technology might assist in what they're doing. There are lots and lots of places where this can happen. Tons of them. And I think there's a really great chance for data scientists, even if you feel you don't want to get involved in politics, you don't have to. I mean, a lot of what happens at local government is not politics. It's just people trying to get stuff done, right? We see national politics at that level, but a lot of local politics isn't like that. It isn't as kind of red or blue or whatever it is. It's really just you have stakeholders. They have different ideas on what needs to happen, but they're not fighting each other. They just have different points of view. And if you can bring in technology to help understand the points of view and help come to some solution, then everyone is satisfied. No one walks away thinking it's a zero-sum game. And I see this happening, I should say, in Utah a lot, where even though Utah is perceived from the outside as this red state, I think internally there's a lot of understanding that people need to work together to make things happen. And it's you see that there's opportunities to do stuff there.
Yeah. I mean, I think in general, local politics tends to be less divisive because, there's a road, we need to fix it.
Right.
How do we get the money or hire someone to fix it?
And I don't want to minimize the importance of policymaking at the national level. That really governs, the big money and the big enterprises. But a lot of stuff happens at the local level as well. And that has real effect. I mean, if you come up with a better system, like you said, to help, manage resources for fixing potholes, people really get affected by that. I mean, that's a real thing. It may not be a big thing that splashes in the New York Times, but it's an important thing. And if we're willing to say, okay, it doesn't have to be a high profile, but it has to have impact. You're a database person, you know how to manage data. That's a big thing. A lot of what local governments struggle with, how to collect data, how to manage it. There's a lot of places where computer scientists can help and with local government and do good things without it being political or controversial anyway.
So thinking like an economist, I guess what kind of incentives would you suggest for governments to encourage more data scientists to get involved? I don't really know how a pro bono system works for lawyers.
So the pro bono system works for lawyers because law firms and law schools enforce it.
Okay.
In other words, law school, not enforce it, but they strongly encourage. There's a culture built up around it, right? So, it's understood that if you work at a law firm, you'll do some pro bono work, and that time is covered. It's like the old Google 20% time used to be, right? There's a cultural sort of built-in expectation that you will do this. And I would like to see any department that teaches data science to strongly encourage students to look for opportunities to do pro bono work, to help them find those opportunities by building connections with local government, and then telling local authorities, hey, you have some data problem. We have students who can help. We can do some consulting for you, and it's pro bono work, so hopefully will not cost you too much. We just need your time and your expertise to understand the problem. I think that's one thing to do, and if we can pitch local governments on this, it would be great. But again, people are very busy, and there are lots of issues with data privacy. There are a lot of issues that it's not that simple. It'll take effort to do it. But you can even do this, right, even across a university, right? So one thing we do at Utah, right? So we've been building up our data science program. And one of the ideas of the center we're building up is to have people from across the university who have data questions come and ask us and see if we can help out with some of these things. And I think there are lots of places like that where you can start, and then that can lead to one more thing can lead to another. We've had people from the local government come and talk to our data science students about some of the questions they're looking at. And I think we have to start there.
That sounds great. I mean, maybe this is something you could pitch to CRA, like some kind of endorsement of a pro bono system.
Yeah,
we don't have to come up with a solution, but just
now that you're making me think about it, maybe I should write something out.
Just a memo that says, departments should do this because it would be good.
Right, because a CRA has a lot of clout. I think when the CRA say things, people listen. I respect the CRA and the CCC a lot. For many years before I was on the board, I've always thought they were doing an excellent job. And I think you're right. If they were to come out and sort of make guidelines, this would be helpful to people. I think we need some examples to say, look, it can be done. Right. Otherwise, no one will believe it. So I think I need to sort of put my money where my mouth is and make this happen in Utah and say, look, we can do this. Let's see if we can do this somewhere else.
Could be an interesting initiative. Yeah, definitely something to think about later.
Definitely.
That's it for the podcast. I hope you enjoyed it. Tune in to our next episode where I'll continue talking to Suresh about algorithmic accountability and fairness. We'll also discuss how to get involved with the CCC and other similar organizations.